So today we will discuss the integrated rate law. Basically, this is only valid for the cases where A is converted into its products, and we find these types of reaction 99% of the reactions are when A is converted into A means any kind of species which is converted into the product, right? If we want to write the rate for this reaction, remember this is for the zero order reaction, right? So the rate for this reaction will be, we know that the rate is equal to R, which is equal to K concentration of A 0. Okay, there's another way to write the rate as well, that is in terms of instantaneous rate, right? I hope that you have studied this as well. Rate is equal to R, here 1 minus 1 delta T. Okay, we won't put delta because it isn't the average, it is the instantaneous rate, and it's like this, dA upon dt. And one we have basically we have wrote the coefficient 1 upon 1 because here the A doesn't have any kind of coefficient, means 1, and that will be written as the denominator, right? So this is both. So these both are basically equal to the rate. Now we can basically compare both of these, and it can be K A. We get A naught is basically means 1, right? A naught is equal to minus dA upon dt, and we know that A naught is equal to 1, right? This is the basic rule of mathematics. Now we can write this as K is equal to minus dA upon dt. Now this will be equal to this will be equal to minus K dt is equal to to dA. Okay, we know when these types of terms emerge, we do integration, right? I can write this as this as well. Wait a minute, I can reciprocal this and write this. dA is equal to minus K dt, and we know when this type of term emerge, we do integration. So let's do integration of this, right? So K the constant, which will be also included in the integration as well. Here write K, and we will do the integration. It will be, so in integration we basically set the limits. So consider that let when time is equal to 0, so the concentration of A is basically A is equal to A naught, where A naught is basically the initial concentration, right? A naught is the initial concentration when you have said the time is equal to 0. Then when time is equal to basically T, then we'll say that the concentration is A is equal to A. Basically this concentration is known as the remaining concentration. This is the remaining concentration. So right, so here we will write as when the concentration is, we write this with another color so you can understand. Okay, when the concentration is right, when the concentration is A basically, so here the time will T. When the concentration is A naught, like the initial concentration, time will be basically 0, right? So this is, we can put this as a concentration of A, which is A naught is equal to, basically K is a constant, right? So we won't add K, and here put T, and here 0 and T. This is like this. Now we will integrate them, and the following answer will emerge, which will be a minus a naught is equal to minus k, which will be t minus 0, right? Now a minus a naught, let's solve this equation. A minus a naught is equal to minus kt. Minus k multiplied by 0 is obviously 0. So the equation which we have right now is basically this. Let me correct this, right? Okay, let's simplify this as well. It is now a is equal to minus kt plus a naught, or you can say it is a is equal to a naught minus kt. Like, this is the formula that you have to basically learn, and this is the most important formula, right? You have to learn this, which is basically, let me basically here a is your concentration, concentration of a at any time. Basically, it is your remaining concentration after the reaction. Then a is your, like, a naught is your initial concentration. A naught is your initial concentration, right? Then we have k, which we are well known that it is a rate constant, right? And then we have time, change the time at which concentration changes from a to a naught, sorry, a naught to a. Like, let me write, t is the time at which concentration changes from a naught to a, right? So I hope this is clear to you, right? So now let's talk about the graph of the zero order reaction, right? Let's talk about the graph. Right, let's talk about the graph of concentration in terms of time, right? This is your graph. Then this is basically your concentration A. I can write this as well, and this is basically the time. Okay, the formula which we derived was basically this: a is equal to a naught minus kt, right? And as you can see here, a is on the y-axis, right? So I guess it is like this equation. Can we rearrange this equation? If we can write this equation as a is equal to minus kt plus a naught, right? Now as you can see that this a is lying on the y-axis, so maybe this can be written as y is equal to mx plus, like, minus mx, sorry, only mx plus c, right? And this equation is for the linear graph. This is for the linear graph, but you can see over here that this k constant is negative, right? So it means that there will be negative graph. So it will be something like this. It will be the graph will be straight line, but with the negative. Like, if someone asks you that what is the graph of a zero order reaction, so you will see there's a straight line graph with negative slope, Let me write this over here. Straight line graph with negative slope, this theta, right? This is the negative, right? So I hope this is clear to you. If you have any kind of questions, you can ask me in the comment section. We're very glad to answer you guys. Like someone asks you that what is the graph of zero order reaction, so it is straight line with a negative slope, because here we key k is basically the rate constant is negative. So I hope this is clear to you. If you have any kind of queries, you can ask me in the comment section. We're very glad to answer you.